I don't know what any of this shit is, and I'm fucking scared.
First, you're gonna tell me about this science stuff.
Sorry about that. What is a scientist?
You caught me like I'm experimenting with
Science!
It's like magic with electricity.
I know that. I'm not stupid. I'm smarter than you.
The smartest scientists in the entire world all agree
Science is a liar sometimes.
Seriously, this could not seem less scientific.
Those idiots don't know anything about science.
It's science.
I believe it's pronounced science.
This is the least scientific thing I've ever seen.
So I'm just experimenting with them.
You be quiet.
Thank you, scientist.
I was up in the office at my job today, and I heard some kid that I've worked with plenty of times ask somebody else, "Hey, have you ever seen the show on Netflix? I think you should leave." And it was like, "What?"
Get over here.
Actually, don't. It's funnier when it's screamed, especially when there's people around that don't get it.
Here come rapid fire quotes.
I hope you weren't planning on talking about anything else for the next half hour.
Yeah, we're going to reenact 3 seasons right now.
So I was shown in the I Think You Should Baseball Instagram page, because I was like, well, do yourself a favor if you like baseball and you like this. And I get to, there's one with I think it's a good idea and I stand by it. Ruben Rabasa.
Right.
And he goes, I don't know if I know that sketch. I was like,
Fuck
what
you.
do you mean you don't know that one? He's like, I got to be honest. I don't know that I've seen all of season 1 yet. I go, all right, well.
So what are you doing with your life? Right.
Yeah, right. I mean, I get it. You want to keep watching seasons 2 and 3 over and over again.
Yeah.
But you're missing what kicked it off.
You're missing the bedrock.
Yeah. He was like, so what? He's like, do you know where in season 1? I was like, it's going to be a guess, but I'm pretty sure it's season 1, episode 3, about the third or the fourth sketch in, if I had to take a wild swing at it. He goes, that was really precise. I was like, I'm pretty sure I'm right. I'm not 100%, but
I wouldn't bet against you.
It might be episode 4. Same. It's not the first one. It's a couple in of the sketch of the episode, rather.
So yeah, I think you should leave. If you have not seen that, then I don't know. Go listen.
Then almost
you probably don't know
the,
us. Yeah.
And half the quotes in the intro don't make sense to you, as opposed to the other half of the quotes, which also don't make sense to you.
Yeah, those are. I think you should leave. Futurama, Matt Pike, Half Baked,
and
Disenchantment.
Yeah, and Always Sunny. Yeah. So the science is Disenchantment, and that is it's actually Abby Jacobson, I think her name is. She was one of the gals from Broad City.
Okay.
But you did point out that she does sound very much like Amy Wong from Futurama, at least in that specific.
Yeah, I thought that's what it was from, because I'm not familiar with the source material. But I should know it because it's the intro for... Oh, sorry. As you were sipping.
Guise of science.
Hello, y'all. I'm Chris.
I'm Charles. And we're talking about science.
Yeah. And I threw that at you right as you were taking a sip. My bad.
Absolutely. That's quite all right.
We're still working on chemistry here. We've only known each other a quarter century.
Yeah. And as we've already stated, we don't do a lot of episodes on chemistry anyway, so thus it needs more work.
That's right.
Hello. What the hell was I going to say? There was a thing I wanted to bring up about... I don't know. It'll come back to me. It'll come back to me when we're not supposed to be talking about it, so...
We'll seg right into it.
Yeah. What do we got?
Tonight, the plan was to talk about... So we've been kind of talking about black holes in pretty much all the physics-based podcasts. They come up, in particular in the Brian Cox podcast from 2 ago. They came up as far as being the Rosetta Stone. And Stephen Hawking also came up. And Stephen Hawking is kind of synonymous with black holes because that was one of the big things that he did in his life. I believe there's on his tombstone, his form or his equation for the temperature of black holes is actually etched into his tombstone. So he goes hand in hand with that. So I think we were planning on talking about Stephen Hawking and deep diving into black holes somewhat.
And it kept. I feel like we were gonna talk about him a couple of times, but then it was Brian Cox happened, and then Interstellar happened. Because again, we have to phone it in every now and again with research. Now we're actually going to talk about him until the next time we have to bring up black holes.
Yeah. But at least now we'll have a base. Everyone will understand a little bit more maybe and kind of be able to follow along. I don't know. I do my best. It's not an easy topic for sure. Stephen Hawking was an incredibly smart guy. I mean, the tragedy of him suffering from ALS, but still being able to figure out ways to pass along what was in that exquisite brain of his is pretty amazing in itself.
And had a really good sense of humor about him.
Yes. Yeah, he was in all the funny stuff.
Yeah, he was in Simpsons, Futurama, with Family Guy. Well, Family Guy was just outright making fun of him. He wasn't in that necessarily.
Like it or not, he was in Family Guy.
Yes. He also did a. I don't think we brought it up in the Brian Cox podcast, but Brian Cox was asked to do something for like a filmed sketch for the Monty Python reunion shows that they did. Stephen Hawking still had to be alive, so at least, I don't know, like maybe 10 years ago or so. And it's Brian Cox talking about how the song Great Big Universe that they do is scientifically inaccurate. And then you just see, much like Monty Python is very good at, a very small dot getting larger and larger and larger in the background until you see that it's Stephen Hawking, and he slams into him with his wheelchair and knocks him into a river.
Because Brian Cox was being nitpicky, right? He was
Yes.
kind of like, yeah. I mean, and obviously he wasn't wrong, but yeah, it was shut up.
Yeah.
So they both have good sense of humor on them. So yeah.
And Brian Cox will say things like, "Imagine that," and the Big Bang.
He was being the polite and fascinating version of well, actually.
Yeah.
Yeah.
Well, actually sounds charming out of British.
Out of his British, sure.
Out of his British, yeah.
Yeah. Not like that.
That's not right, you fucking cunt.
Right, yeah.
Fuck off.
Not that British. That's a different British. But Hawking was also British.
He was.
Yeah.
It's too bad they didn't give his voice thing a British accent. That would have been fun.
Yeah. and you know, it's funny. He was his voice thing took a significant amount of AI. It's fairly advanced for, you know, the things that we use today. But he was kind of outspoken. I don't know if he was being cheeky about it though. But he said that AI is going to be the doom of humanity. Pretty much, he was not a fan of AI, or at least thought that it could lead to bad things. And particularly, he was saying if it ever gets to the point where it's smarter than us, look out.
Yeah,
now it's smarter than us.
It'll just cut the cancer out of its body and move on. I don't need this thing. Yeah. It's killing me.
Be the new dominant. Yeah, it's a stupid flesh sacks holding me back.
Stupid flesh sacks holding me back.
Interesting.
I think he wrote that in one of his rhymes. Stephen Hawking was also a big rapper.
Yeah, he had bars. Well known for his bars.
Let's see, Stephen Hawking. Nope, lost it already. I was going to say something about that.
A cool thing about that equation that we just referenced. So it's the temperature of black holes. It's the equation to figure that out. I don't know if I could. No, I probably can't share it, but maybe we'll share some kind of link. They'll find the link to it, but I have it written out here. But the cool thing about it is it's one of the first equation that combines some of the main pillars of physics that normally don't play nice with each other. So there is both quantum mechanics come into it, as well as relativity. And then there's also gravitation and thermodynamics. So all of those ideas mix into this equation when you're talking about how to find out what the temperature of a black hole is. So it's kind of a revolutionary idea in that regard.
And quantum and relativity are the ones that really don't play nice with each other, right?
Right. Yeah,
Like
relativity works very well on the scale of the big, and quantum works very well on the scale of the small, and we don't know how they mix.
In a black hole, duh.
Yeah, and that's why. If we can figure those out, there's a lot of stuff going on that it would be a game changer.
And you just can't get in them. It's
you can get in them pretty easy. You just can't get out of them.
Fair enough. Fair enough. Yeah.
And you can't tell anybody what you saw. I think that's the craziest thing, because even a walkie-talkie, like if you're on one side of the event horizon with a walkie-talkie and I go on the other side with a walkie-talkie on the other side of the event horizon, I hit the button and talk back to you, because space is contracting or receding or flowing away from you at the speed of light or faster than the speed of light. That walkie-talkie signal can't get back to you because it has to travel through space from one point to another, but space just keeps sinking. So you'll never hear me.
Space itself just collapsing around the sound.
Yeah. Just being
throwing it back in.
Flowing downwards.
That's crazy. Right into a bookshelf, apparently, right?
That's right. into all the bookshelves of all time. As far as Interstellar would have you believe.
So what I know we brought up a little bit, but is there like a little bit more in-depth answer about Hawking has the theory of stuff gets out, like it doesn't get out through the way it came in, but it's getting out somewhere, and therefore it can potentially be reassembled. Like, is that related to his what's that thing called, equation, or is that just solely what the temperature would be inside of the black hole?
So I think the equation is just the temperature.
Okay,
but the other thing you're talking about is Hawking radiation. That's been named after him because, I mean, when he came out with the idea, it was kind of mocked almost, that it was like, that's ridiculous. Nothing comes out of a black hole. Once it goes in, that's it. It goes in. But it's like, it's well known already that a black hole is like, if you see an active black hole, it's one of the brightest things you're going to see, like as far as telescopes and shit like that. And that's because as the matter is orbiting around, it's not like a vacuum cleaner. Again, it's just a place in space where it's crazy massive. That's really all it is. And we have no idea what comes out rather, because of the mass pulls shit in. So like light will actually orbit around the thing. And especially with supermassive black holes, because they're so big, the speed that it orbits at, the friction, the energy that it gives off, that accretion disk, it's crazy bright. And you can see it from, billions of miles away. That's how we've discovered various things.
And that was your point about Interstellar, with you don't know that planets could exist that close because they're not necessarily getting the warmth. You're just able to see the light.
Right. It may not
able
be...
to see the light will get to you, but it doesn't necessarily mean that you'll be heated to a temperature that would sustain life, kind of thing.
Right. Yeah, it may not give enough energy to support a planet. And there's also the problem, like I said in the Interstellar podcast, that's just visible light. There's a whole bunch of light on the spectrum that we can't see. There could be various ultraviolet light that's more energetic. And we have on the Earth, like the sun also gives off ultraviolet light. Everybody knows about it. You need sunscreen, you need UV glasses and all that kind of stuff. But our atmosphere and our magnetic sphere do pretty well at keeping a lot of that out. If it was multiplied the amount that it was actually giving off, I don't know that our atmosphere could keep it out. It could even, be powerful enough to strip it off. So yeah, living on a planet like that, orbiting a black hole with that much, when you're that close, all the UV rays that would be whipping around there at such high speeds, I don't know. It wouldn't be good.
So what, like if so you're saying that? Oh, all right. Here's the question that I was trying to ask in the first place. So we can detect ultraviolet light though, correct?
Yes.
Like, so is ultraviolet light also getting sucked into black holes, or we're not sure?
Yeah.
Okay.
It would be. Even like technically the cosmic microwave background radiation is getting pulled in as well if it gets close enough.
That motherfucker can't escape?
Even that, nothing.
Shit.
Yeah.
Wow.
And that's everywhere.
It is. Quite the formidable foe, that
Meet your
cosmic
match.
microwave. That's fucking wild. So then, all right, back to still on that. So if it's sucking in ultraviolet radiation, then how is the ultraviolet radiation getting to the planets and jacking them up and stealing their atmosphere and poisoning life?
I guess kind of similar to why it's harder for us to launch something directly into the sun versus launch something out of the solar system, because of the speed that it's moving at and the direction that it's coming in. So this ultraviolet radiation isn't necessarily coming from the black hole. It's coming from elsewhere, but just moving, getting caught in that gravity and orbiting close.
Oh, okay. So it's not radiating from the black hole itself, but it's getting drawn closer to, and because you're close to something so massive, more of it's going to get drawn in.
Right. Yeah, no, and that's not Hawking radiation. We're just talking about black holes in general. Hawking radiation is fucking mind melty. So
let's melt.
Yeah, I'll do my best here. Okay, so outside of the black hole, the space right outside, there's even a point where if light gets too close, it's going to get sucked in and get pulled into the event horizon. So there's a point between that accretion disk and the event horizon that's empty. However, we've talked about it before, empty space is not necessarily empty. It's an invisible froth. So there are virtual particles that pop in and out of existence. And the virtual particles are both matter and antimatter. Typically, in normal space, they pop into existence, annihilate, and disappear. So there's no violation of conservation of energy and stuff like that. They borrow energy from the universe and then give it right back. So everything kind of cancels out.
And they also go,
that's
when it
they do.
happens.
Yeah. When they annihilate, it sounds like an old man getting hurt. That's true.
Shit. So, and accretion disk, I brought that up to you before. That's what was the fancy word? The Schwarzschild.
The Schwarzschild, or I don't know how to pronounce it, but it's something like that. But that's the radius. So,
okay. So that's that which isn't the same as the accretion. The accretion disk is the event horizon, right?
The accretion disk exists just outside the event horizon.
Okay.
The Schwarzschild radius and the event horizon are basically the same thing. So that's just there's a guy named Schwarzschild who came up with an equation and or more accurately, I guess, solved Einstein's equation and noted that everything even the Earth has this point where if the mass exists within this radius, it basically would become a singularity. So the Earth's Schwarzschild radius is somewhere deep within the Earth. Most of the mass of the Earth is actually outside of it, and that's why it doesn't collapse. But in the case of black holes, the mass is actually inside that radius, and that's why it collapses. So that radius and the event horizon are the same thing. It's just the point where if all the mass is gathered within that, it collapses. And it varies based on how massive something is.
All right.
Yeah, so that was kind of the first guy to point out, hey, Einstein's theory is kind of broken. If we do this shit, we get bullshit numbers, or we get something that goes to infinity, or dividing by zero, whatever the thing is that breaks it. And that's a mathematical singularity. And it was like, this can't exist. And then we found them.
Neato.
Yeah.
Well, since I'm already asking you the questions that I texted you earlier, hey, do you know how to answer these questions? So what is, and this is me pulling this directly out of Thor Ragnarok, what is an Einstein-Rosen bridge?
That's another word for a wormhole. It's
Okay.
just, it's something that I guess is predicted by or allowed by general relativity. It's a theoretical hole in space, kind of, where if you were to picture space, kind of like Interstellar, they explain it pretty well, that if you were to picture space as a piece of paper and fold the paper in half and then punch through from one side to the other, that you could technically move through space quicker.
Okay. All right. Yeah, that was just the first time I ever heard that term. I should really Google this.
Save it for this show.
Yeah.
It sounds like a could be an accountant name.
Let's see, Einstein Bridge. Oh yeah, so that's the other thing that Dr. Banner is saying. He says it looks like it's a Einstein-Rosen bridge inside of a collapsing neutron star. Like that when they're talking about like the devil's anus that they have to fly back through.
Whoa, yeah.
Yeah. I think I don't remember which is inside.
Collapsing.
Yeah.
A collapsing neutron star. I don't know, would it collapse to a black hole? Like, and how long does that take? That sounds like I gotta reroute I hit the firewall, I gotta reroute through the mainframe.
Yeah.
Just throwing out technical terms that sound reasonable.
Yeah. You just said a few things in a row. That's all that was.
Yeah, neutron stars, as far as we know, I mean, I don't think they collapse, because if they collapse, it's just going to be a black hole, and that I don't think happens slowly.
I guess maybe, and like that was the other thing about that. That was just in the sky on a planet in Ragnarok.
Yeah.
When it was
like, look at that.
Yeah, look at that thing that's up there that's in the sky all the time. But that's what, like, the shit would fall out of that, right? That's the stuff that would fall out of that onto the collector's planet. So I guess it was kind of going both ways.
Yeah. Yeah, exactly. Yeah, with a wormhole, it's not like a black hole's a one-way trip, but a wormhole theoretically is a path that you can go through. It's like Chutes and Ladders.
I don't know that I ever won Chutes and Ladders. I feel like I never fucking won that game.
It's a horrible game. And if you play with the wrong kids, you got to make sure one of them wins so that it doesn't end in a fist fight. It's the worst.
How often do you have the thought of, do you have any idea how much this wouldn't suck if you guys didn't just fight?
Oh, all the time.
Multiple times a day?
Candyland, we don't really play anymore. And if we do play Candyland, it's my wife has the cards rapid fire, goes orange next, green next. But like, she doesn't give any time, right? It's you gotta get in there, pay attention, because we're moving. Because otherwise, it ends poorly.
It's like Casino Candyland. You don't have time. We playing this or not? We playing this or not? If you don't want to play, get out.
Get out. Get away from the table.
Yeah. You can't sit at the table unless you're playing.
That's pretty accurate.
I know it's not a new idea, but fucking yeah, National Lampoon Vegas Vacation did it, but or some version of it. But to just be able to play like those kind of games at a casino, like play board games at a casino for money.
What was what number am I thinking of? That was Vegas Vacation. And he said,
yeah, heads or tails.
7. Nope. Yeah.
Yep. How many fingers am I holding up behind my back? I think might have been one of them too. I would crush categories at a casino.
I bet you would.
I would murder that game. Or so I think. I might be overly confident. And there could be just a bunch of college kids, fucking English classes, English majors, just coming in. It's like, yeah, I know every word.
That would, yeah. I guess it depends on your sobriety. I think you know a lot of words.
I do, and it's amazing the ones that come out when I am drunk.
They're not usually real.
No. There'd be a lot of rulings against me. You have the dealer and just somebody looking up the words each person says. It's a judge.
Pit boss is a dictionary. Yeah. Spelf,
Good,
get him out of here.
Spelf. Vleeb.
You gotta go.
By the way, the Pit Bosses Dictionary is a good band name, or at the very least an album.
I could see that. Yeah.
Write that one down.
You write it down. I don't have anything for that. Someone write it down and email us.
Yeah.
We remember.
Let's see. Oh, all right. Stuff for movies. There we go. I got it. I get us back on course.
Okay. Yeah. And Schwarzschild Radius, or however you put. I'm sorry, I'm butchering that name, but that's somebody's name. Oh, which I found out there was a guy named Peter Higgs, and that's who the Higgs boson is named after. Because I remember we asked that at some point. So yeah, there was one guy that was like, "There's got to be some shit that like makes all the shit into shit," and they named it after him. And he was right. And they were like, "We'll name it after you."
In spite of how crudely you presented your argument.
It's vulgar, but you're right. God damn it. God damn it, Peter.
He's out of line, but he's right.
So yeah, you got this event horizon.
Mm-hmm.
But if you were near the event horizon and crossed over to the other side of the event horizon, physics math says you would not notice anything. There's no difference from one side. We're assuming you got through the accretion disk and didn't get x-rayed into pieces or whatever is going through there. So now you're in that empty space. You cross over. You don't know. From one side to the other, it looks exactly the same. And again, space is frothy. So all this froth is also falling with you. So you're both crossing in. It doesn't look like anything is going on at the event horizon. Now, imagine you're in a rocket in this empty space near the event horizon. You didn't cross it yet. You're on the outside, and you're accelerating away. So you're moving away, but space is moving in. So now you're actually going to notice these virtual particles that are moving past you through space as you're, relatively speaking, sitting still just past the event horizon. Because everything is moving in, you're accelerating away. You're not actually gaining. You're not getting any distance between yourself and the event horizon.
But all the stuff that's getting sucked in is now moving past you.
Yep.
Well, you're kind of, wow. That's like in It's like in cartoons when they're trying to run away on the rug and they're just a cat's running away on a rug and a dog is behind pulling the rug back and they're just kind of running in place and all the shit's going past them.
That is a brilliant analogy for a black hole and Hawking radiation.
Nice.
Yeah.
Say cartoons pays off.
Right.
Because how else can you explain ridiculous things that don't sound real?
Yeah.
With other ridiculous things that aren't real.
They go hand in hand. Yeah. So if you had some kind of detector, if you're sitting there floating and getting sucked in, this detector doesn't pick up anything. But if you're trying to accelerate away and all this stuff is moving past you, it's going to seem like space in that area is not empty, that it's just filled with stuff. And it's all relative based on how you're moving, because the waves aren't actually canceling out. They're getting pulled past you. So this is a weird sentence, but the existence of particles near the event horizon depends on the observer. It's relative, not absolute. So already people are like, fuck you, Stephen Hawking. That's a bunch of bullshit.
That's so you can see particles only if you're looking at them.
Mm-hmm.
But I guess it's only if you're able to look at them.
Yeah. Yeah, you have some
which
kind
sounds
of
ridiculous, but like, how much other shit like that has come up in like science evolving, like Louis Pasteur and germs and shit like that. Like, it was these things that we cannot see are there, and there's evidence that they're there, and it's like, but we can't see them because we're not able to observe them, pretty much, because they didn't have microscopes and shit yet.
Yeah.
And then they got technology to see it, and then suddenly it's like, oh shit, look at all this stuff we can see now that's on a microscopic level.
Yeah, it turns out the dudes that we were like, no. That was right. How about that? Like watching an episode of House, where it's like, oh, Dr. House, you're crazy. I was like, oh, he was right again. How about that? Season 7.
Season 7. All right, Dr. House. I know we've said this before, but you've definitely had too much Vicodin this time. Oh, yeah? Then why did I just perform surgery on my own leg? Son of a bitch. He did it again. Credits.
I replaced my own brain with someone else's brain. Saved everyone. I think that happened. You can do self-brain surgery.
Sure.
Yeah.
Sure you can. The professor in Futurama did it, so.
No, that's all you need.
Absolutely. Again, cartoons are real. I believe that's what we've established so far.
Mm-hmm.
That was a real tough pill for me to swallow as a kid. Just like, nah, cartoons aren't real. You can't just do all this shit. And I was like, oh, fuck. What's the fucking point?
Things hurt, and yeah.
You can't just stop in midair if you run off a cliff, and then as long as you don't look down, you can just walk back to the cliff.
You can't run through a painting of a tunnel as long as you believe.
Yeah, all that stuff. Very upset. And that's what got me asking questions. I was like, all right, if this isn't real, then nothing's real.
You're not far off, though. The more we talk about science, the more it seems like everything is just kind of what we perceive.
And so, getting back to observing things as you're going through or as you're accelerating away from a black hole. So, if one were to kind of like, let's just use the completely unrealistic example of you're flying your spaceship and it breaks down right near an event horizon, and you're trying to get the engine started, and it's just not turning over. It's the mass of the black hole is relative to what exit velocity you would need to escape being pulled into that, right?
Yeah, it's a different escape velocity depending on the mass. Sure.
Yeah, so the bigger it is, obviously the more exit velocity, just like a planet.
Yeah.
Essentially with right.
Yeah, you gotta be moving.
I was just gonna ask, where were you when I was trying to learn this shit in high school? A year ahead of me.
Yeah, I was also in high school.
Sometimes I was down the hall, sometimes I was
Right.
2 floors up.
You definitely saw. We ate lunch together, I think, a bunch. So
Yeah.
I definitely saw me.
Why weren't you asking these questions at lunch, bro?
Right. We were making plans. Fuck
Yeah.
that. Yeah.
How many conversations at a lunchroom in a high school go like, no. This is what we're gonna do. And it's just like, ugh, none of this is gonna work.
And nothing had anything to do with school.
Yeah. We've just been doing that. We're not gonna do that now. This is the time we don't have to school. Except for the nerds.
All right. Speaking of nerds, all right, strap in for this part.
Ooh.
So what we've said so far is the easy stuff. So as you get further away from the black hole, these virtual particles can actually become real. They become a little bit more stable depending on how much further you go. The reason for this is...
And this is further away from the black hole?
Yeah, not much further, but like once you get into regular space, they pop in and pop out and annihilate. Okay. It's just like somewhat further away from the event horizon.
Okay.
And the reason for this is once you cross the event horizon, based on the Penrose diagrams and other mathematical theories, but time and space basically switch properties. So like, no matter what you're doing right now, you're moving through time. The future is inevitable. When you cross the event horizon, the singularity becomes inevitable. Space, no matter what you're doing, you're moving through space. So like that property kind of flips. And in a sense, time becomes a little bit more malleable, however you pronounce that word, because you can see light both from the future and from the past, some that might be in before you or after you, depending on how it's moving and shit like that. So it's not really an easy concept to grasp physically, but mathematically it works. Yeah.
Man, it's like some reciprocal fraction shit.
Yeah, and now to get even weirder, something that we've talked about in the past, antimatter, in essence, like a positron is an electron that experiences time in reverse. Reverse charges, like we've talked about that before, right?
Yeah. Okay. I remember that.
So now you're in this area beyond the event horizon where time and space are reversed. So positrons can exist there because time is reversed, and that's how they experience time, versus their corresponding electron, let's say. And again, we're talking about virtual particles on the other side are now further away, maybe, from that event horizon that they can exist where they're real. So basically what happens is the black hole absorbs this negative energy and gets smaller, while the corresponding virtual positive energy escapes. That's Hawking radiation.
Holy shit, dude! There has not been a sentence in a while that I've barely been hanging on the entire fucking time. Holy shit!
Yeah.
All right. So the
It's yeah.
all right. So I might just have to ask you to say something like that, something similar to that again. So yeah, no, I can't even recap. What the fuck did you just say?
A way to think about it is imagine these virtual particles popping into existence.
Mm-hmm.
You can kind of think of it as the positive energy particle pops up on the correct side of the event horizon.
Okay.
The negative energy particle pops up on the black hole side of the event horizon. So the negative one gets pulled in and slowly shrinks the black hole, and the positive one escapes because its pair got pulled in. It can't annihilate, and it escapes as this radiation.
And we don't know why, or why is the negatively charged being pulled in and the positively charged not? I mean, right, because of what you just said, but why are they popping up on those two sides in the first place?
That they don't. That's just kind of the simplistic idea of how to think about it.
Okay.
And it's because the reason why it happens is because of the reversal of time and space on one side of the black hole versus that relative virtual particles that can exist on the other side of the black hole. So it's a little bit deeper than that. But the way to boil it down and think about it in simpler terms is one pops up and gets away, and the other pops up and gets sucked in and shrinks the black hole somewhat. Yeah.
So do they think that there's some type of and you notice I'm not saying we anymore because I don't know that I can say we about this. Do they? Do
this is
they,
Steven. You say Steven.
Did he believe? So is there any type of correlation to moving through space with time as an with the future as an inevitability being tied to positrons, and when it gets reversed inside or negatively charged or the opposing side of the pair being tied
the antimatter,
to,
we'll say.
Right, the antimatter moving through time with space, the singularity of the space as the inevitability.
As far as how can we harness it, kind of.
I guess that's probably what I'm getting at. I don't know for sure. I did just say a lot of words that I am uncertain about.
I don't think that there's anything that we can harness from that. But there's a couple of crazy ideas that come for that. So as crazy as this sound, it's actually been proven. Like we're at the point where this is real. This isn't, like I said, people in the 70s, people laughed at Hawking, but now it's like, holy shit, he's right. So the implications of that have gone into other things, like Kip Thorne that we talked about in Interstellar. One of his big theories is the holographic principle, and that can kind of borrow stuff from this Hawking radiation. And
now that was the 80s sitcom about a principal who was never actually in the school, right?
It was Tupac. It was Tupac, the principal. After he passed away.
Shit. Fuck yeah. My apologies, you were saying.
The holographic principle is a whole, like, I don't have notes on this, so I'll do my best with it. But the idea is Kip Thorne basically figured out that the possible arrangements of molecules is in any given space is equivalent to the perimeter of that three-dimensional space, not the area. which is very important because the area would be 3D, but the perimeter is only 2D. And the possible configurations are only related to that two-dimensional space. So what that could potentially mean is that things that get sucked into the black hole, there may not be a singularity within that event horizon that everything's get pulling. The information may be stored on the event horizon, on that two-dimensional space. And he basically extrapolates from that everything we see may be a 3D representation of a two-dimensional space. And that it's not.
Holy shit.
Yeah.
It's all this, hey, you know how everything's 3D? Well, what if it's not? It's like, oh,
Right.
God damn
what
it.
if we just think it's 3D and that's how we experience it, but it's not. Yeah.
To quote Mitch Hedberg, man, I should have just said, yeah.
Yeah. No, this gets it gets like melty as you get onto the edge of the cutting edge of physics shit, where we're still like maybe like some of this stuff, like even because like I just said, Hawking radiation is not a maybe anymore. It's like no, this shit happens, and that's fucking weird. So like, all right, if that weird shit happens, what else? What else we got?
Fucking hey, man.
Yeah,
this is heavy.
And one of the cool ways, actually, this is a cool thing. One of the ways they figured out that this kind of stuff is real, in a lab, they've done things to recreate black holes. They'll actually have a big pool with a drain, and the drain is it pulls the water in at supersonic speeds, so it's faster than sound. So they'll send a sonic wave, and like there's an actual event horizon where the sound can't cross this barrier because the water is moving in faster than sound.
Holy shit.
So they actually can, so they can recreate kind of stuff like that with water and sound to represent black hole shit and do experiments.
That's fucking crazy.
Yeah.
Is there videos of this shit? Not that you could probably see any of it, but
probably. I would imagine. Yeah.
And is that where they learned how to make the airplane toilets like flush really hard from that experiment?
I think that came first. Maybe they built on that technology.
Oh shit, I do is this. They seem to say. Speaking of seem to say, I have been fighting a pee, but I cannot. Again, don't feel obliged to talk. I will be back.
Okay. Oh. So, for anyone listening, so we were talking about Hawking radiation, just to go back to that. So Hawking radiation is thermal radiation. So you can actually measure it using Hawking's formula to get the temperature of a black hole. So that's where all of that kind of ties in together. And the thing about black holes is the bigger they are, the colder they are. It's one of the only things in existence that get hotter as they lose energy. Everything else, typically, as you lose energy, it cools down, but they actually get hotter as they lose energy. And the Hawking radiation would snowball, theoretically, because they're big and they last a long time. But theoretically, the Hawking radiation would snowball as they get smaller until the evaporation kind of, I guess a chain reaction would take over, and then they pop. And according to Roger Penrose, he believes that pop should send a bunch of photons out and should cause a bunch of gravitational waves that could potentially be seen through other dimensions, or if there is another epoch, however you pronounce that word, that you would be able to see them from one to the next if there is a future universe after ours dies. But the that formula to get the temperature. Like I said, it uses a bunch of various constants. The wavelength of particles, which is the quantum side, the speed of light on the relativity side, the gravitation and gravitational effect due to the mass of the black hole, and thermodynamics is mixed into there as well.
Oof. Man.
Yeah, I just spit a whole bunch of nonsense. So, welcome back.
Oh, thanks for having me, buddy.
No problem.
If the microphone was stronger, you would have thought that matter and antimatter was annihilating out of existence like rapid
In
fire.
your turlet?
It was just
Yeah.
I really do have to get one of those giant urethras like you have, because these regular sized ones, it's just, I'm wasting so much time.
It's all about muscle control too. You got to be able to push. You know, when I was younger, and I would see older dudes, or more accurately, hear older dudes at the other urinals in the bathroom, I'd be like, "How does that happen? Like, why does it take so much effort to pee? Like, there's just no problem." And here I am. Now I get it. I know I have to go, but it's not doing it on its own. I gotta coerce this.
Yeah, well, since you brought up old dudes in toilets, and to how once you decide something's funny at one point in your life,
That's it. You're locked in.
Being in a public restroom and then just hearing an old dude in the stall just ripping ass, like really fucking farting, and like really getting the acoustics of the bowl in there. Like, it doesn't sound real. Like, that's how incredible it sounds. It's like, this, it's not going to get any better than this. I don't know that anything's going to make me laugh on a visceral level like this does still.
Yeah.
It's amazing.
I swear, I wish I had the confidence of an old dude at the YMCA. Like, they do not give a shit. It's just, here's my balls. What?
Yeah. I mean, and does that come from just your entire life of you've just walked around with your balls out? And then you're just like, I've always done this.
Yeah, or does it switch flip? Do you get to a point where you're like, fuck towels? Whatever. You want to look? It's your problem. Yeah. You don't want to see this? Don't look. It's very...
Your eyes are up here.
Right.
Yeah, old dude's balls. Nice. Good work.
Yeah.
Nice job, us. Did you have a fun filling time again?
I did. I think I spit more facts, less jokey, more facty.
Okay.
I think. I don't remember now. That was like 48 seconds ago.
I don't remember which one it was, but there was one of them that it was like you were delivering it like it had almost a Weekend Update energy to it. Like, you were just kind of,
oh, nice.
This is this thing, and I'm gonna that's obviously what this is. And like, it was very serious and dry and like delivered very straightly, and it's pretty funny. Again, I don't remember.
Why would they name it 9/11 Airlines? That reminds me of that tragedy. They say Weekend Update, I think Norm. Yeah. And then I think Norm, I think that joke.
Yeah, it's one of the best ones I've told. Well, since we're on the topic of Weekend Update anchors, very quickly, I would like to bring up that I saw Colin Quinn the other night in the city.
Oh, nice.
Do stand up. Yeah, that's the first time I've ever seen him do it. That wasn't in like an amphitheater with tons of drunk idiots screaming at it. It was just like him just like working pretty low energy. I think my favorite thing about him is that his obvious vocal crutch is, you know, I don't know that he says it the exact same way twice in a whole set.
Okay.
it'll be,
different ways of saying,
Yeah, like, well, you get here on the subway, and it's in and like he never says either word the same way twice in a row, and
yeah.
it's just great. I enjoyed it. I mean, yeah, obviously I laughed at his jokes as well, but that's just added gravy.
Well, as a fellow mushed mouth man with funny ideas, he's an inspiration for me.
He does like I can kind of get his voice, but like to do like the mumbling he does and like 3/4 of a word that he says, like just enough of it's so difficult.
Yeah.
He's
not easy.
No. Very unique. And who was he on? He was on Remote Control with Kari War to bring it all
That's
back
right.
to something else we've done.
And she cures cooties, as we all know.
She does. She does, in fact. I've been cooties free for 30-something years at this point now. 34
Since
years.
Anaconda came out.
Yeah. So where'd you leave off with your solo?
I think it just kind of talked about one of the things I wanted to bring up to you, actually. I said this while we were gone, but what's cool about black holes is they are one of the only things, or if not the only thing in the universe that as they lose energy, they heat up. Everything else, as you lose energy, it cools down, but they are, the bigger they are, the colder they are as compared to the rest of the universe. It's only as they shrink that they actually heat up, and it's because it's negative, it's antimatter rather than regular matter and stuff like that. It's causing them to to lose mass.
There's something to this antimatter.
It's a thing.
Seem. Yeah.
Yeah.
But because that's so if it gets smaller, it gets more intense with heat, right?
For black holes, yep.
Yeah.
Yeah.
And everything else, the smaller it gets, like the less powerful it is, kind of thing. So is there
black holes get smaller because they're losing energy. So with everything else, it's just as they lose energy, the colder they get. Because, I mean, heat in general is just a measure of the energy in molecules. Like when we're talking about what's the temperature outside today, if it's hot out, it's because the air molecules are very energetic. As it gets colder, they get less energetic.
And heat makes the molecules dance and jump around and stuff, and that's what makes it warmer out?
Yep, exactly.
Oh, shit.
And this is actually, so I'm in the process of reading Neil deGrasse Tyson's latest book. And this is from the first chapter. He noted that it's infrared energy that causes heat, and our atmosphere is good at trapping. It's translucent. It lets the visible spectrum in. The visible spectrum interacts with the molecules, and when the molecules give off energy, they give it off in the infrared version. And our atmosphere is good at trapping infrared energy in, which is why this planet is not freezing to begin with. And that's typically why in the summer, like, afternoons are hotter than the mornings, just because it's been all day. The sun's been warming up the earth, and the earth has also been giving off this heat that's been kept in. So it's not just the heat from the sun, it's the heat from the earth as well.
Fun fact about that, I was unintentionally doing my own experiment. I found out experiments when I started working mornings. I would be outside at work before the sun was up. And then the sun would come up, and then like an hour or two later, it would get breezy. Like the wind would pick up a little bit. And it was consistent. It was happening every morning. And then I Googled it. And it turns out the initial heating up of the Earth's surface after the sun comes up causes moisture to evaporate up out of the surface of the Earth. And that changes the pressure. It's high pressure and low pressure, just a very basic, same principle as a weather system. They like cause each other to move in opposite directions, and that makes it breezy in the mornings.
That's so fucking cool.
Right? It's fucking bananas. Like, I love also just the idea of just like, this keeps happening. Why? And,
and someone figured it out.
Yeah. That's my favorite part even more, that somebody else figured it out and I can go, oh, okay, cool. I don't want to discover new shit. I just want someone to reaffirm something that I've already seen.
Right, yeah. Okay, this is real and it's a reason for it. And okay, I'm not crazy. That's the important thing.
Yes. Not
and
about
then there's
that.
people out there that are going, they're lying to us. You're fucking morons. Sorry.
There is always some they that is lying, but they can't possibly be as big.
Yeah, not about that kind of shit. Not about the like, ooh, this is exciting. Why does this happen? Let me figure it out. Yeah, there's people lying about where your money's going, that they're really using it for something else. There's people lying about why we're doing this thing because it's a cover up and they're doing that thing. There's not people lying about why the fucking wind moves or that the sun is heating up molecules. And just like, I hate you. I hate you so much. Anyhow.
Wind, surface, Earth before
Colin Quinn. Back to Hawking.
Hawking radiation.
Yeah. Hawking. So some interesting things about Hawking. So that's radiation, that's black holes. We kind of, I think, beat that to death. But I just want to, some other cool things about Hawking was he bet, or made a gentleman's bet, I guess, with Peter Higgs. He said we wouldn't find the Higgs boson. And we did.
Ooh.
So he admitted he lost his bet and said Peter Higgs should be nominated for a Nobel Prize for predicting that exists.
In England, aren't gentlemen's bets just called bets? Like, isn't that already implied?
Yeah. Right, you're a gentleman by default.
Yeah. It's like I thought that's where we started with. I thought we were already gentlemen. So we're the only ones allowed to make bets. It'd be great if that was the case, and then he's like, all right, Hawking, you lose, and fucking, what's his name? Phil Bose? No, it was Higgs.
Peter Higgs. Phil Boson.
Yeah. Peter Higgs and Phil Boson. Of the legendary British pop duo Higgs Boson. They had their one hit in the 80s, Bet You Can't Find Me. And then in parentheses, hide and seek. I don't even remember where I was going with that anymore. Oh shit!
Philip K. Boson.
Yeah. Oh man. Well, that's the shit. And there's very big of the two of them.
Thank you for finding that.
Yeah. What other neat stuff you got? About Stephen
All right, so I sent you that John Oliver video where John Oliver interviewed Stephen Hawking.
That was real good.
And and it was funny. We can share that in the links. But one of the things that John Oliver asked was, what is your idea that hasn't been used for science fiction? Because most of his ideas have been pulled into various things. And he said imaginary time, because most science fiction writers don't understand it. And Fair enough, because if you thought that other shit we talked about was confusing, wait until we talk about imaginary time. Because
Yeah, how does that work outside of a preschool classroom?
okay, so it's a trick. It's basically a trick with math, and that's kind of what it boils down to. So when it comes to things like the Big Bang, there is, if you're doing Einstein's equations, again, you get to a singularity where everything contracts to the point where the entire universe is in one spot at the same time, and math just breaks. You get things that come out to infinity, dividing by zero, all that good stuff. So the trick is, so if you picture an x-axis, you have a line going across. You pick any point on that x-axis.
Mm-hmm.
That's a point in time. If you take that x-axis at whatever point and flip it at that point to a y-axis, now what you're looking at is everything happening at the same time. You have to think of it that way. All the things on this timeline on the x-axis are now flipped so that everything happens at the same exact time on this line.
So if I may,
yeah.
just to help better illustrate it and also help me better
Yes.
understand it. So let's say that along this x-axis, you stop at 1980, the dot that would represent the year 1980. Everything that happens in 1980 is now that represented within that y-axis.
So if you stop it at January 1st, 1980 on the x-axis, and then you flip it so it's a y-axis,
Right.
Everything from the Big Bang until the heat death of the universe happened on January 1st of 1980.
I am glad I asked you for clarification, because holy fuck, that's way more stuff than I thought.
Yeah, it's everything ever.
I was out here like, oh yeah, you and your cousin and a couple of our other friends that are all born in 1980, and John Lennon got killed all in the same, all at once. But no, it's fucking everything ever.
Everything ever possible.
Why?
And the
why
way you
then,
do
how,
that,
or whichever order you want to do those in.
And the reason why is because you're doing math going back to the singularity, and math breaks. So you're like, oh fuck, I can't do any math further back in time. So you do that flip. The way to do the flip is you multiply whatever by the square root of -1, which is which is an imaginary, because you can't get a square root of -1. It's an imaginary number.
Is that one of those
really
what's his
exist.
name numbers that we discussed? Grossman numbers?
Grossman.
Grossman numbers?
This is your standard run of the mill imaginary number trigonometry. Like we may have learned it back then. Yeah, this is in like Grossman numbers is a whole nut, like even imaginary and regular numbers and fractions and decimals, they weren't good enough. Like this Grossman numbers have different properties from numbers in general. Yeah, that's a whole. Yeah.
Okay. All right.
These are just regular imaginary. But the bottom line is, I mean, this sounds very complicated and is very complicated, but to simplify it, because of that singularity, to avoid that singularity, you multiply by this I. So you're flipping everything on its y-axis from the x-axis. Now you do your math, and you're in like a different. I think it's called the x-axis. I think it's called Minkowski space, and then the y-axis is called Euclidean space. So you're doing all your multiplications in this Euclidean space, which basically has no boundary. There's no time boundary. There's no t = 0. You can do whatever you need to do mathematically. Then when you're done with your equation, you can divide and you can undo that original thing that you did. So you can do your equations with no worry about any kind of singularity, because there is no time boundary. You get your answer, and then you flip it back from Euclidean to Minkowski space, which is reality, and you can get your answer that way.
Shit.
Yeah.
So And that, so one of the, man, I'm going to try my best to get this one out. Oh, man.
Yeah.
All right.
He was a very smart man.
That's another thing, by the way. Like, I don't care that he's dead, and this goes for everyone that's dead. Like, well, he was very smart. Nope. He is still very smart because nobody else is there yet.
Yeah.
So he is
Right,
still
yeah,
very smart in my eyes.
Right.
He's still
he holds the record for being smart.
absolutely. He's got the strap. No one's fucking challenging him yet. He is
Right.
still the reigning smart.
Right, come for the crown.
Yeah. All right. So, man, now I'm trying to remember the thing I was going to ask. All right. So, but that's kind of how stuff starts. Like, ideas start, like, all this stuff that comes out of doing math is it's like, all right, well, it works mathematically. It works on its most base, simplest level in how we interpret the universe. Is because math can and will be right over and over and over and over again every single day. Or not just, you can replicate it every time. Once you have it figured out, it works the same way every single time. So by doing that, you like, that's kind of the framework for what's eventually going to be a bigger, crazier idea. And it might not have been, it's how you paint in. It's like how you fill in the rest of it. That's where all like the experiments and the coloring in and finding out exactly how it's like.
Yeah.
Man.
It starts in theory.
Mm-hmm.
And once it gets, all right, this theory is sound. We've done all the various equations and this looks good. Then it goes from theory to experiment, and then the experiments try to prove that whatever crazy equation the theorist came up with is accurate. And then we get cell phones and whatever else. All the good stuff that we have.
Yeah.
I mean, I don't know where understanding imaginary time will lead us, but who knows? Because I'm sure we didn't know the other shit.
Yeah, like, and if it's everything that ever happened all at once, like maybe that's like a multiversal thing, or just time travel. If everything's happening all at once, then you can pinpoint your exact spot. You could be inside the Tesseract and try to tell yourself stay home and fucking stay.
Yeah, stay. You gotta stay.
I didn't stay when I told you I thought I was gonna.
Don't leave that girl.
One of my favorite things is how that voice sounds as good as I hoped it did in recording. It doesn't sound the same through this, but when listening to it played back and recording and properly produced, it's like good. That's
No, the out of nowhere, no, you're not got me every time.
No, no.
She was like, I'm coming. He was like, no. Nailed it.
That's fucking crazy shit, man. What do you got, a nut?
One more weird thing. So according to Hawking, and there was, I forget who else, there was someone else that he worked with, but they came up with this idea that if you go back far enough in time that there is no time, it actually gives way to space. There's a certain point where time no longer, because what we're living in now, the 4-dimensional space-time, he's saying that this singularity, as you approach it, time gives way to space, and time no longer exists, but space still does. So Hawking was a proponent of the multiverse theory, to think that there's other instances of universes outside of our own in some kind of greater hyperspace type thing.
All right. So just to help me visualize this again. And so x-axis, you got 2 arrows pointing outward on either end. and then halfway through, it's time on the right, and then it's space on the left, or like maybe it's like a transitional thing where it's like kind of like a crossfade with audio where the space gets a little bit heavy or a little bit more prominent and the time becomes a little bit less prominent kind of thing, until on either ends of the spectrum it's all time and all space on the other end.
So I think rather than an arrow on both ends, you're going to have a point on one end. The Big Bang is going to be the start of time.
Right.
And as you get back to that, before that is something that we don't understand. I guess is the best way to put it. But in Hawking's theory, it would be before that. If you can call it a before, there's still space. But the idea of time doesn't come into play until the Big Bang and until things like entropy and stuff like that starts to actually exist.
Because that came up in the Interstellar episode again. It's like if you're in that fifth dimension, you're outside entropy and you're outside decay, and you're like that doesn't all affect. So and that and those are all. For lack of a better way of putting it, like byproducts of time, of the passage of time. If time isn't passing, theoretically, those things aren't going to happen.
Exactly. Yep. Yeah. So and it's a dot on one side, but an arrow on the other.
Oh,
that can go and that fifth dimension, you can step back and you can look at any point along that line, or what was that called? An array, or when it's a dot?
A dot, then a line with an arrow on the end. Yeah, ray sounds right.
Yeah,
I'll allow it.
Yeah. So the ray of time rather than a timeline.
So, all right. Still trying to wrap my head around this one. All right, so you have the ray of time, and you have the dot, the line, arrow at the end. So during that line, there's a trend, like I was saying, the transition of it's predominantly time and a little bit of space, or am I still not looking at that in the way that you're explaining it? Like,
okay,
like for example, like let's say there's 100% space on one end and no time, and they each move up incrementally to where they eventually pass each other.
So I think it's more at the dot, it's kind of just space.
Okay.
And then time is born. And then space-time exists as is. It's not like time doesn't take over and then there's less space and it's more time. They are now one going forward forever.
Okay. All right. So then, okay. Yeah. So, the arrow represents time.
Yes. Yeah, that's actually perfect. Yeah, it doesn't exist before that dot. But then once that dot happens, now time happens and time continues.
See, I had this idea during the Interstellar episode, and I didn't say it out loud, and then I listened to that one again, and I was like, fuck, I should have said that out loud, so now that it's come back up, like, in obviously a very abstract way, because there's no other way to look at this, but like, the idea of, like, heaven and paradise in religions is, like, one of the, like, you're just there. You're there with everything. You're there, everything all at once, and there is no passage of time, and nobody dies, and everything is just there. Like, so then, again, this is K through 12th grade in a Catholic school, so that's probably always in the back of my head. But like, yeah, just that idea of heaven is just outside of time, or whatever the afterlife is, whatever you want to call it, is outside of time, and just there's only space, and it's more abstract than, oh, you're there with all your dead pets and everyone's having ice cream at once. And
you want money? You could just think about it and you have money.
Yeah. instead of that, it's more of a just like, no, you're just part of everything, and everything coexists at the exact same time and just is.
I mean, yeah, that's a metaphysical way of looking at it, and I can't imagine a third party or an outside actor or something outside the universe. So like that idea of heaven or hell being something different kind of doesn't jive with me.
Yeah.
But the idea that energy can't be created or destroyed, and here we are, beings of energy, like when we pass away, what's to say that our energy doesn't reunite with the potential energy of the universe in general? I mean, I don't know that you have a human consciousness, but who knows what the fuck after that?
Yeah, it's energy just always kind of moves into something else, right? Or at least it affects something else, and that kind of keeps moving. So yeah, what's crazy is the more we talk about this shit, like the more the George Carlin big electron thing that he talked about at, I forget which special that was during, but yeah, just
1994. But yeah.
When I couldn't possibly handle the shit that he was trying to shove in my head.
No, but he's not like, he's a smart guy in as far as not only the way he looked at day-to-day shit, but the way he did look at the big picture. Like even his I pray to the sun and I worship the sun and pray to Joe Pesci. those lines are yeah.
God damn it.
He's deep.
Yeah.
Yeah.
Fucking A. Man, that's wild.
Yeah.
Black holes are crazy.
Yeah, and can you imagine talking about this shit as your fucking job? Like, or not even talking about it, coming up with this, figuring this out. Like he deserves that equation to be printed on his grave, because holy shit.
Yeah.
How did you think of that?
Like their job is, all right, I've finally done enough math that I can explain this thing. And my job is, like, I put something into an Excel sheet and go, ugh, I've finally done enough math.
Right.
Ugh. And yeah, it's like, it's looking at it like, and I might be grasping at straws. Nope, that's not a good analogy. Never mind. Cool. Not grasping at straws. That was a good analogy for what I was trying to come up with. But no, just like understanding math to that level. And just being excited to do more math because what you're going to get out of it. Like, it feels like for like physicists and I guess mathematicians and like it's all the result. It's not the journey. It's all the destination.
Yeah.
Whereas like
once you can make it work.
Yeah. Or, I guess it is. Maybe it is the journey then, because you know where you're trying to get to. And it's how do I get there? And then you're trying. And then, man, I'm talking in circles right now.
That's the scientific method. Yeah. Once you have your hypothesis and then you pull in your. But and that's the thing about once you get into the experimental side where observations go, what the fuck? that wasn't supposed to be like that.
Yeah.
Then you got to kick it back over the fence and tell that, hey, theorists, you said this was going to happen, but that's not what happened. That's way off. And then the theorists got to like factor that in and figure out all right, well, like for example, all right, we got gravity. Everything that spins around the center of mass of the galaxy based on the gravity. As you get further out, it should be slower because the further out you get, that's more energy spinning outward. The gravitational pull shouldn't be able to hold that based on the mass of the stuff that we could see. Mm. Great. Kick that over to the experimental physicists. And they go, we're looking at the stars. They're moving way quicker than your equation says. Kick it back over the fence. And that's when the theorists go, there's got to be some mass that we don't see. And then dark matter gets invented. And then the more they start to pick apart, where it's, all right, so we'll throw this other mass into the equation because there's clearly some mass that we can't see. And now the equations work. And now when the experimental physicists look at it, they go, oh, you're right. The stars move according to that thing you said. And when we look at these faraway massive objects, the light warps the way you said they would based on this invisible mass. So that's where the idea of dark matter came from. It came from the math and how it didn't agree with what the observations were. And then they had to somehow correlate the two.
Fucking A.
Yeah.
That's crazy shit. All of it. All of this was fucking bananas.
I hope we laughed on this episode because there was a lot of just holy fuck.
We did. Yeah, there were jokes.
Yeah.
There were definitely jokes. Yeah.
There's always jokes.
Fucking the British pop duo of Higgs boson. Come on.
Yeah, true.
That's a clip right there. Oh, shit. Well, under the guise of science at Gmail, Facebook, and Instagram, guys always spelled Guise.
Under the guise of science, we're on YouTube, we're on TikTok, and on X, we are at Science Guys.
Is it really called
also,
X now? Like officially?
I guess so, yeah.
Ugh.
That's what my app says after I updated it. It moved from screen 3 to screen 4 because of alphabetical order. It's now X. Yeah. I like Twitter better. It makes more sense, but Elon Musk is... Let's do an episode on what a douche Elon Musk is.
And yeah, so many times where I was like, oh man, this guy seems like he's really cool, and then he just...
Yeah, no, he could save the world if he wanted to, but instead he wants to fucking fight Mark Zuckerberg, who, by the way, will beat the fuck out of Elon Musk.
Yes,
I don't know if
will.
you've seen Mark Zuckerberg training. Yeah, no, he's a beast.
Yeah, he's...
Compared to nerds, not compared to, actual beasts.
Yeah, no.
Yeah.
Again, I will... If you want to have the battle of the marks and have Zuckerberg versus Henry, fucking...
Yeah, right, yeah, no.
Sexual chocolate, world's strongest man, father of a hand born of a lady. Mark Henry will rip Mark Zuckerberg's arms off.
I feel like if we had a barbecue and Mark Henry was the cook and he was actually manning the grill, he could beat the shit out of Mark Zuckerberg while manning the grill and wouldn't burn anything.
Nope.
It would be fine.
Every burger would be as rare or well done as somebody preferred.
Right. But he could beat up probably Elon Musk and me. He could probably beat me up. I'm fine with that. But Elon Musk, don't bite off more than you could chew.
Nice.
Yeah. Fart Barf is fun. Listen to Fart Barf ASAP.
See you next time, fuckers.